a lot of times we're faced with in our organizations, do I use UAF or SySML? If I had, a dime for every time somebody asked me that question, I would be home relaxing on my farm in front of my pool and not have to work anymore, right? So this is actually, Laura and I did this original presentation last year. We've added to it. And so some of the information that you'll see in here will look familiar. So I'm going to talk a little bit about architecture, the essence of why we do it. And then I'm going to go into enterprise architecture versus a system engineering, architecture using UAF or SySML. And then I'm going to get into, and Laura touched on this in her presentation, I call it the architecture continuum, right? Because it's something that we don't talk enough about. And then I'm going to give you an example of what that continuum might look like, and then we'll wrap it up. And then it'll be time to go get ready for the reception tonight, right? All right. So the essence of architecture, why do we develop architectures to begin with? It's, we're not going to develop an architecture for a simple system, right? It's usually to manage complexity, right? That we're trying to solve a problem that's highly complex. And today these problems are getting more and more complex as we go on. The other thing that we use with architectures is to manage the communications, because we have stakeholders from executives down to, the welder on the shop floor, right, that we need to communicate with. And how do we do that? And there's different levels of architecture that we use to do that. Sometimes, through the architecture, we're just trying to express a solution of some type, right? And that solution may be for a system, or it could be for an entire enterprise, right? And then that enterprise, we're trying to support the decision-making process. We're trying to give our leaders who have to make tough decisions, right, better information so that they can make better decisions. So that's huge. The other thing that we use architectures for is just the only thing constant is change, right? I mean, change is constantly coming in. That goes back to complexity. The more complex our system is, the more likely we're going to have to deal with changes as time goes on. And so how are we going to deal with those changes? So having a well-defined architecture can really help us manage those changes as they come in. A couple of things, though, that have come up in the last few years as, enterprise architecture and system architecture and model-based system engineering has come up is that somebody will present something that looks really cool, right? And it's like, somebody that's never worked on a car before, you pop up the hood and you see this really cool looking engine. It's like, yep, okay. But, it's a gas guzzler and you can't afford it. So, so it doesn't mean it's a good design, right? Complexity does not equal good design. So, we can have a bad architecture and it may reflect a bad design as well. So the other thing I wanted to point out that gets lost is that we talk about modelers, right? But architecture is a tool, right? You wouldn't just bring somebody up out of college and teach them how to use CAD and they have no domain knowledge if they're trying to design a vehicle or an aircraft, right? That requires domain knowledge. That requires some engineering discipline, right? So one of the things that I've been on my soapbox is that, a modeler is not necessarily an engineer. Now you can take somebody that knows Cameo or knows Rhapsody or Spark Systems very well, and maybe they don't have that domain knowledge, but you need to couple them with somebody that does, an engineer that understands the domain and the problems that they're trying to solve, okay? All right, so again, engineering and architecture. So when I look at what we do throughout the engineering life cycle, there's always a place where an architecture, a well-defined architecture can help. So whether I'm, we've heard a lot about capabilities and definitions there. So that can facilitate, a decision maker who's trying to determine what capabilities are required to meet a mission objective. I want to go and negate a target. And if I have what are the capabilities that are required for me to go and negate that target, right? And what happens if I can't field a capability? Can I still meet my mission objectives? Or how well can I meet that mission objective, right? Interface migration. Things, again, they're constantly changing. So how am I going to, as new interface standards are coming about, how am I going to incorporate those into my systems? Because if you don't plan for that, then somebody's going to field a system out there and you're no longer going to be able to talk to them and you're broken. System integration, again, how am I going to fit all the pieces together? You know, I have small kids, or I still have one small kid, and Legos are huge for them, right? So how am I going to put all these things, all these Lego blocks together? Well, if I don't have a manual, if I don't have, you know, the directions that show me how to build the Death Star out of Lego blocks, I'm not going to be very successful, right? Verification, again, an architecture can help define what those verification cases need to be in order to determine that you're building the product correctly. And then last, we really don't talk about this too much, but obsolescence, right? Systems are getting old and I need to replace them. What's the impact going to be when I go to replace that component, when I replace that system in the field? How is that going to change and affect, again, my ability to meet my mission objectives? Can I still do it? So well-defined architectures, you know, and these products play a key role in just about everything that we do throughout the engineering lifecycle. So enterprise architecture. A lot of people talk, okay, I need an enterprise architecture for everything, but what are we really saying, right? When we say I need an EA, what is that? What are they for? And so you can see here, it's really about aligning organizations or a government agency, you know, to align what they're trying to do with their strategic business goals. So you look at UAF, which you guys are all familiar with UAF and how it's laid out. One of the top things in that periodic table of views, right, is a strategic views, right? What are those things? And so how are we laying things out? So an EA takes a holistic view of an ecosystem and it lays it down, right? They're the blueprints for how we want to very precisely define the organization or where the organization is going to go in the future. So EAs are critical for most organizations to have defined, and a lot of them don't. That's changing over time, thankfully. But having a well-formed EA really provides the basis for how rapidly, you know, you can field things, how rapidly, how agile the company can be with its changing ecosystems today. So UAF, we're all familiar with UAF, right? Has anybody in here never heard of UAF? You've been in here all day? I think we're all familiar with it, so I'm not going to spend a lot of time on that. But UAF is the language. It's the industry standard language for developing enterprise architectures. Why frameworks? I think we're all familiar with why I want to use a framework, because the UAF, it's going to provide a common vocabulary, common mechanisms for us to integrate these things together that we're trying to align. It allows us to define, you know, all the piece parts of our organization, and that UAF has done a very good job of defining everything that might be needed for that EA. What we don't talk a lot about, especially, you know, enterprise architectures, the system architecture, right? And how that relates to things. So when I go to a system architecture, I'm not really talking about an enterprise anymore. I'm talking about one thing, right? So in this diagram here, I've got the hybrid SUV, right? And its piece parts and its components and how those components relate to one another, right? So the system architectures are really meant to ensure that your design is going to meet cost, schedule, and performance of the program, but also I can scale it. It's got reliability factors built into it, right? That's what that architecture at the system level is trying to do. So Laura touched on this already. What's in that system architecture model? You know, it's the structure, it's the behaviors, it's the requirements, the parametrics. The thing I want to stress is that these things are not standalone, right? When we're building these things, they're interrelated. There's a relationship. If I have a requirement in my architecture, then I should have something that is showing it's satisfying that requirement. Just having a requirements model out there, right, is one view or a piece of an architecture, but it's not the whole architecture, right? So if I have requirements in my model, I want to see what is responsible for meeting that requirement. We call it the subject of the requirement. And I want to understand if I've got a subject for that requirement, how am I going to check to make sure that requirement is being met? That's my verification. That's where the parametrics can come in. So this is, it's an integrated piece of information or collection of information, that goes into that system architecture. Just a quick plug for those of you, we are working on SySML 2.0, which is the standard language that we use for system architectures. It's in beta release. We hope to have the full release out by September. All right. Excuse me? Yes, actually. Yep. Coming up quickly. So again, I think Laura talked about this. When I look at architectures, I can have a descriptive architecture or I can have an analytic architecture. The one thing that mistake that we see all the time is I try to develop one model to rule them all, right? And we want to get away from that. So the first thing when you're looking at something, I need to define what it is I want to analyze, and that goes into an architecture. And then I'm going to define how I'm going to analyze that. And that may be in a separate model. But the key is with the languages that we have between UAF and SySML, I can relate them together. Whereas before, early in my career, when I did a lot of modeling and simulation, I would get a system specification and a document. I'd read through it, so I understood what it was that we were trying to analyze. Got it wrong most of the time, the first time. So then we would build the simulation, have a meeting with the customer and say, is this what we got? Or this is what we have. Is it meeting your needs? And no, because you got the system wrong. It's not what we're trying to build. So tying these things, the descriptive model to the analytical model is huge. And we can do that today. And that's really what this chart is getting at. All right, so enterprise versus system architecture. I've touched on this. So when I'm trying to decide what it is that I have, one of the first questions I look for is, who are my stakeholders, right? Am I trying to build an architecture for the guy that's going to build the system, or am I building an architecture for the executive of the company or the PEO, of a defense organization? So who's the stakeholder? Who's the customer? And then I start looking at, well, what's the scope? What are the concerns? What answers need to be met? Are they trying to use this for acquisition, right? So are they trying to make determinations, on what to buy or what to build, right? Or is the scope, no, we're trying to I need to define the thing that's going to be built, right? So the scope is very different between your enterprise and your architecture. So those are the top two things that we should be looking at when we're trying to decide, am I building an enterprise architecture or am I building a system architecture? So, and that leads to, well, am I going to use UAF or SySML? And the answer is, well, it depends. And it depends on those stakeholder needs, and it depends on the scope of what the architecture is. Are you trying to decide, if I have a bunch of capabilities, right, and I don't feel the capability, can I meet that mission objective? What happens if one program office, and I've got 8 of them that are putting different or supporting different capabilities and providing different functionality for a given capability? What happens if one of those programs falls behind schedule? So am I going to use an EA for that? Or is that a system architecture? Or is it both? Right? We'll come back to that in a minute. So the bottom line is you want to use the right tool for the right job. Just don't go, well, I'm going to use SySML for everything. Can I? Yeah, you can. I can build an enterprise architecture with SySML. Is that the right tool? I'm going to do a lot more work. Can I use UAF for a system architecture? Yeah, I can. There's a lot of things in there, though, that I don't necessarily need because I'm defining a system, right? So again, we want to be smart in our decisions, and so choose the right tool for the right job. System of systems architecture. How many people have fun with system of systems architecture? Right? It comes up a lot. And so I'm not going to read through the bullets, but is a system architecture, is that an enterprise architecture or a system architecture? You got it. Yes. Again, it depends on, even if I have a system of systems, a lot of people automatically think, well, that's enterprise. No, it goes back to, you guys are smart. It goes back to who's it for, right? What questions are they asking? What am I trying to solve with the system of systems architecture? I may be trying to determine in the system of systems how well I can achieve my mission objective, which is going to have strategic goals and other things related to it. It's an EA. But I may, with my system of systems architecture, may be trying to figure out how am I going to interface system A, B, C, and D, and E? How do they plug in together? What type of equipment is going to be needed? How am I going to test that? That's a systems architecture, right? My EA is not going to answer the mail for the test engineer. It's not going to give him what he needs to go out into the desert and test the system. But the systems architecture down at that lower level can. I'm not going to say it will, because you still have to build all the information into it so it can be tested. So, all right, so you've seen this before. So this is kind of that continuum of architecture to where, you know, even if I have an enterprise architecture, and I think you should always have an enterprise architecture of some sort. Either it's how we're going to operate our business, how we're going to design, develop, and deploy systems, you know, to our customers, right? Or it may be, you know, a capability EA to where you've defined the capabilities, you define your goals, and you've got, you know, behaviors and resources that you're using in order to, you know, meet an objective. I think you should have that enterprise architecture is like with the model-based acquisition group, you know, your AOD, what is in that, right? What are those things that you have to have in order to get a solution out the door? So that's very much in that EA realm at that top layer there. But then as I go down, and this is where the confusion really starts, is I'm at that logical layer. I can use UAF or I can use SySML in there. And I go back to think about what you're trying to do at that layer, at that level. Am I still answering enterprise type level questions, or is the intention that I'm going to use this to put on contract so that the solution can trace directly to my logical architecture, right, and satisfy system level requirements, right? So there is overlap in that layer, and sometimes you may end up, I have an EA and I have a system at that layer for a given AOD. There's nothing wrong with that. My caution there is don't try to develop one model to rule them all. It never works. We've tried it hundreds of times and it's yet to ever work. So don't. If you need multiple models, just make sure that you define what their intentions are for. I'm going to define this at the logical level using UAF because it's still part of my enterprise and I have to answer that mail. And I'm going to define a separate system, logical system architecture, because I'm using that to answer system level type questions. We're not quite sure what the optimal solution is, so we're going to do some analysis of alternatives using a system architecture to determine the optimal solution that we want to go out and buy or build, right? And then these things should all trace up. The nice part about what we have and the tools that we have today, UAF is built on SySML. So we can trace all these things up. We can relate everything together. And there's a number of ways that you can do that. Last year, James Martin did a presentation at this No Magic Symposium of all the different ways that people, oh, there he is, that trace SySML models to UAF models. So there's a number of different ways that can be done. And we should continue to do that because we want this continuum of architecture to where we're using these tools and we're relating them together. So as an example, what that continuum might look like, if we consider, I have a fires capability. I support PEO missiles in space right now, so this is a real problem that we're working on. I just took out all the details to protect the innocent. So we have a PEO, and he needs to know what the mission impact is going to be on the objective, and basically in order to be able to get a target. If one of his program offices falls behind schedule, and there's, what, 8 program offices? So if one of them falls behind schedule, how is that going to affect his ability to meet the mission objective he's been given? So within that, so that's very much an EA type thing, right? So what we're developing is an enterprise architecture that defines a strategic roadmap for the entire organization. And then we've got mission objectives in there, and we have scenarios, we have threads, mission threads that are being defined. And we've gone through and we've done the strategic taxonomy. So we have all the capabilities that need to be developed over a period of time, a long period of time, in order to meet that mission objective. So those things are being related to the program offices, right? They've got capability configurations, so on and so forth, and they've got schedules. All that is being done in UAF, and it's wonderful. The program offices, some of them are developing their logical architectures in UAF, and some of them are developing them in SySML, but they're still system level, and that's okay. We're working through those details on how best to trace back up into that EA, since we have both, because we have 8 different program offices. We didn't control what they decided to use. Some of them just chose UAF because they thought they had to. Other ones made a conscious decision to use SySML to try to keep things simple, and that's all they really needed. So, but they're developing their system requirements. They've got logical structures, they got behaviors, and then we're relating that back into the EA. So that way, if one of those programs falls behind schedule, that schedule is actually part of the EA already. So they have their suppliers that are developing real solutions and detailed models. And they have schedules. So we're actually tying all these things back as we speak. So that way we'll know if supplier A falls behind schedule, how that's going to impact all the way up through the top. That's only achievable if we link everything together. So this is a very real example of how the architecture continuum can help and answer that question. And I'm a firm believer that if we don't do it this way, if I were to stop at the EAA, right, then I'm missing everything below that is needed in order to answer the question. Because I can put a program, you know, I can do my program level in my EA, but if that's not tied to real things at the logical and in the system architecture level, the design detail, then I don't have a way to truly assess the impact going all the way back up. So this is what we're working on today. It's not done, but that's a real example of how a roadmap, which is really an enterprise architecture, right, is going to meet the general's need on answering the mail of how he's going to achieve his mission objectives, how he's going to defend a certain area. So all that say, in finishing ahead of schedule, so you know, thank me. But whether you're using UAF or SySML is really a question of scope and concerns, right? It's, you know, enterprise versus system. What are we really trying to do with this? And you always go back to, I don't care what you're trying to model, what's its intended purpose, right? What answers, what questions are you trying to answer with the model, whether it's SySML or UAF? You know, together, I think UAF and SySML can provide the complete picture, right? If you're looking at one or the other, you may only be getting half of it, right? And so don't choose one or the other. That's why it's like UAF or SySML. Yes, that's what I'm going to do. And as we go forward, you've got the DoD and the CIO, you know, that are really trying to push for the advancements of these standards in both UAF and SySML. So thank you for your time and questions. 7
questions.
May I ask one again?
Great presentation. I just had a question. When we talk about mapping up from SysML to UAF, are we going to create something like similar to Appendix B in UAF 1.0, where we had like the UAF to DODAF mapping for SysML to UAFML mapping, or are we going to update either the SysML spec or the UAFML spec to include dependencies that trace up to the, like an activity is an operational activity action or something like that? Because It seems like all the mapping right now is manual. Over.
So it is manual. There are mappings, like you said, between DODAF and UAF that make sense. There are some relationships based on the meta types that are within UAF and their SysML type that make that really easy. But I don't know if the UAF guys are planning on doing that as they go forward. That's why I'm looking to Laura and Araya, because they're the ones really to answer that. It would make sense to have that. So,
Question about
Great.
information management.
Roger Bolton from the Boeing Company.
Mhm.
And I'm living what you were talking about. So great. Thank you. Great perspective. My
Thank you.
question you has to do, and this is what fundamentally I'm opposed with a lot of times, is SysML is a modeling language and UAF is a modeling language, but
Yeah.
UAF also comes with a framework.
yes.
So SysML needs a framework. How do you approach that? Do you develop something like using IEEE 42010, or is there a standard framework out there nowadays for doing that system architecture model?
So, yeah.
Well, okay, I agree with you. That's why I wanted to ask.
Well-
Because the problem is my SysML people say there's no way I'm using that UAF framework because that's UAF. I want to know what your opinion was.
So my opinion is that, yes, you have a framework for enterprise. And at the system level, you're spot on. There really is no framework. And so you get a mixed bag of stuff. And the problem that we have today at the system architecture level is that very rarely am I going to build a model that is standalone. Chances are Laura's going to give me a model and I got to integrate it with my model. And so I would even argue that it's more than a framework. It's a standard. It's a modeling standard. And so one of the things that we have, and it's just step one towards that, and I hate to use the term because it means something different to everybody else, is a style guide, right? And so what that means is, you know, every block has to have a name and it has to have a description. Every activity has to have an activity diagram. And I mean, some of it's really silly stuff like that, but where it gets into, and a problem that we've lived, is walk into a place, we're brand new, we're starting on a program, and they're developing an architecture, they're using SysML, and the first question I ask is, do you have data that you need to model? Yes. How are you doing that? Well, what do you mean? How are you modeling the data? Because in SysML, I can use a block, I can use a signal, I can use an interface block. I mean, none of them are wrong, they're all correct. Well, that's where the framework comes in, to where, again, you're standardizing on how you're going to model data, how you're going to model your structure, how you're going to model your behaviors. And that's where constructs there come in. I think it's something that's missing. And we'll get there.
May I offer
Yeah.
pull that thread a little bit, because I think that's an important piece that, like you said, is missing, but there's even more to it than that, right? The style guide is just, am I modeling it correctly, and is everybody using the same sort of,
Yes,
annotation, like in grammar and language kind of a thing? But is everybody saying the same thing, right? Is that, to me, is am I modeling the right thing? And that goes to, in this continuum, right? The traceability between all of these at the seams, like Tony Malia was saying earlier, right? There's a huge knowledge management problem, right? That the undertaking that needs to happen, because all of these teams in a federated set of models that are connected and need to work together to effect an outcome, are they all being, are the assumptions correct? Are they modeling the right things? All these scenarios that you're talking about, right? Is everybody going after the same problem and making the right assumptions? And that's a big undertaking, right? Is anybody doing that?
Well, I think that's where part of the problem that we're trying to solve with the model-based acquisition, right? And it's a start to getting that to where it's a standard way, and it's using UAF, but it's a standard way of how we're going to communicate what is needed and what is expected in the return in the RFP. And so I think that's a start. It's a beginning.
Yeah, I use an orchestra analogy to make that point, right? If all the musicians, all the modelers are using the right notations to write the music, however,
Mhm.
nobody's composing the music, right? Architecting, if you will, and saying play this as your concert, right? And that is if everybody starts, they may be perfectly modeled within each of their little boxes, right, at the enterprise level or system level. However, they all start playing, and it's going to be noise, right? Somebody's got to say, how do they all play together? And that's that big picture architecture definition. Am I modeling the right thing before you say, am I
Well, and
modeling
I
it
go
correctly?
back to that, that's where your EA comes into play. And I think the EA definitely provides that composition that you're looking for. So again, to your music analogy, which I like, all the musicians, they're all reading their part on a sheet of music, and each one has their own, whether they're, the horn section or the clarinet section, we each have our own part. But I may not know, as a former horn player, what the string section is playing, but somebody has developed that EA, that overall composition that determines how these things fit together. That's why I started earlier or stated earlier that I believe that you should always be working from an EA, because that is at least the beginnings of that composition for how all the pieces are going to fit together. It may not be entirely what we need today, but compared to what we've had in the past, and I think that's the other thing that we're learning, now that we're moving away from being document centric and spreadsheets, now we're really recognizing, hey, I need to go figure out I can see that I need to put these things together. Whereas before we didn't even understand that we had to put them together, right? That there were relationships between these things. So I go back to why I believe we should always have an enterprise architecture to work from. And then as we're developing those system architectures, we can see how they plug in. Without it, I agree. You're
Copy
throwing
all,
darts
right?
at a
And
dartboard.
I put it in the chat that we're actually going to an enterprise of enterprises at this
Okay.
point, right? It's even bigger than that.
Yep.
Yeah. Adam Skripchak, Strategic Technology Consulting. Do you have any resources on the movement information from the EA architecture down to the system architecture and back again? So the EA can provide that context of, hey, I need to develop my system. Now,
Do I have any examples of that?
yeah,
No.
or like resources or like best practices on that, because like it's coming up a lot. Like some people, like a system effort will start, right? There's no EA, but the EA does get built at some point. You got to like integrate those things together again or pass data between them. So I was wondering if there was
Yeah, I
any
think
guidance
the
there.
closest thing that I've seen is what James did a year ago, where he did kind of a survey of all the different ways that people are doing that. Is that a best practice? I wouldn't say that, but it is a resource that kind of describes all the different ways that are being doing it. I go back to, I think the first question, mapping, right? How are we going to map these things back together? I think it can lead to that, and I think that would be a great tool to have in the future.
I have a question, a different subject,
Sure.
which I haven't heard come up, and I'm very interested. The lack of architecture basically presents technical debt,
Yes.
I believe. And the technical debt becomes due at some point in time, and therefore there's a risk assessment of the lack of architecture in the process. Like the knowledge is in people's heads, or it's on a piece of paper that can't be found, all these sorts of things. Have you seen any work in this as a justification?
Oh, yeah. Yeah. I'll let Laura talk to it. Yeah.
See technical debt a lot. So we saw technical debt when the government said, give us models in the acquisition, and they gave us text. We got the technical debt right off. We've
Mhm.
seen technical debt when you build a prototype and then you follow up with a model and something changes and you can't assess change. So yeah, technical debt's a big reason to have an architecture. And just one
And-
more thing about, why SysML was useful is because we all had a domain model implied in our head, which was our systems engineering process. And that's what saved us, is because we actually, we knew the song in a general sense that we were all singing at the same time.
Yeah. So to follow up on that, There's been several occasions to where actually I had pushback from doing this. And so I walked through their current program and pointed out all the risk. And then at the end, it was, okay, because you're not doing these things, here is the total technical risk that you're incurring on the program, and it's completely unnecessary. So I think when you walk through it technically to where you show, okay, you can assess this impact. So that can cost you 6 months and $2 million. You can assess this one. So here's the risk associated with that. So it's where you need to work with the program managers, who understand how to define the risk and how to quantify that risk. And when you go through that, then you can really put real numbers back to that technical assessment. And then when you put that in front of them, then they sit back and look at it and say, okay, so your program, I get it. It's been in business for 40 years and you're working on that, but you're planning on, you don't have a replacement and you're trying to extend this out 30 more years. So how much risk are you willing to take?